Consider a beam subjected to a transverse load, and if we cut the beam somewhere along the length, we have a sagging moment causing tensile stresses in the bottom and compressive stresses in the top. And at the centroid, which may not be in the middle of the beam, depending on the section, the stress is 0. Now on a small area element of this section, which may have some arbitrary shape, and the section is in the XY plane, and we'll look at some differential area element that the differential force is acting on. So the differential moment is the moment arm from the centroid of the section, which is y by df. And this can be written as follows by recognizing that the differential force is the stress acting on this differential area element. And now we can integrate both sides to get an expression for the bending moment as equal to the integral of y by the stress over the differential area. Now we can recognize that this bending stress distribution is linear, so we can relate the stress on the top of the section on the distance from the centroid, yc, to the stress acting on a differential element. So that would be some stress over the y distance from the centroid. And if we multiply through by y, we can rewrite this stress as stress C on yc, which we can take outside the integral because it's constant, and that's multiplied by the integral of y squared dA. And this ratio is simply equal to stress on y acting anywhere along that section, and this integral is the second moment of area. So therefore we can write the bending stress as m multiplied by y on the second moment of area. And because we want tensile bending stresses to be positive, at a negative y value along that section, and where the sagging moment is positive, then positive by negative will give a negative stress. So to make the tensile stress positive, we'll put a negative over here. So where y is positive, we have the sagging moment causing compression, and because m and y will be positive in this case, we have the compressive stress being negative. And this will also be true where we have a hugging moment causing tensile stresses in the top of the beam. So because the hugging moment will be negative and y will be positive on the top of the beam, and negative of negative gives a positive tensile stress on the top of the beam. So have a think about this. Please subscribe, like and comment to help me reach more students.